All right, so in section 5, we are going to learn how to use inequalities in a triangle. And what I mean by inequalities is we're going to have greater than or less than symbols when we're comparing different things in the triangle. So the first theorem that we are encountering is theorem 510. It doesn't have a name, so if you were to use this as a reason and a proof, you'd have to restate what it is. For the most part, we'll be using this theorem to solve problems or to find the longer side. And I'll show you what this means in a minute as soon as everybody gets the notes in here. So this one does not have a name. It's a no name. So basically what this theorem is saying is you can tell the bigger angle without pulling out a protractor by looking at the measurements of the sides. So the longer the side, the bigger the angle. So for example, angle C is opposite the 12 and angle B would be opposite the 10. Because the side that's opposite C is the bigger number, I would say that angle C is greater than angle B. So if you do not have any angle measures written inside your triangle to tell which angle would be larger, you're going to look at the sides opposite them. So the side opposite, the biggest side is opposite the biggest angle, and the smallest would be opposite the smallest. Does that make sense? Common sense. So 12 is bigger than 10, and so we could see that C is the bigger angle because it's opposite the bigger side. Anybody need the slide? Another theorem. If one angle of a triangle is larger than another triangle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So now this time they give us the angle measures to figure out which one's bigger. So here, notice that 60 is across from side AB, and the 30 is opposite side BC. So notice 30 is smaller than 60, but if I were to write the inequality, I could say that side AB is greater than side BC because it's opposite the larger angle. So now it's opposite. So before you looked at the sides to figure out the bigger angle, now we're going to look at the angles to determine the sides. Good on that? Okay. In case they said order the sides, how could we know about AC, where AC would fit in? What would we have to do, Michael?
Add up angle A and angle C and subtract from an A and then get what B is.
Good. Anybody know what B would be? Doesn't look like it, but 90. So remember, things aren't always drawn to scale. So because angle B would be 90, then AC would be our biggest side because it's the biggest angle. So over here I could actually put in that AC and put it in order from greatest to least. Anybody still need the slide?
No, I'm good.
Any questions? All right, next one. 512. Again, this one's got a name now, and this is called the triangle inequality theorem. And this one states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So what this would mean is that if I were to add BC plus AC, that sum should be greater than AB. Yes? okay? Then the same thing on the next one. If you were to add A and B plus AC, it needs to be greater than CB or BC. Okay. Then for the last one, if you were to add AB plus BC, it would need to be greater than AC. Use this theorem to check to see if three numbers could form a triangle. We're going to look at an example of it. Anybody still need the slide? Okay, next. Back to that theorem, remember two sides have to be greater than the other one. So this is why if you always pick the two smaller ones, we're going to do an example. So here it's asking us to name the largest angle and the smallest angle. So first of all, let's identify which side is the longest. Which number is the biggest up there?
10.
The 10. And notice that the 10 is going to be across or opposite of angle C. So we would state that angle C is the largest angle. Which angle would be the smallest? Bella? Angle B, because it's opposite the 6. So angle B would be the smallest. Make sense? All right, now, back on our triangle inequality theorem, just to show you how that would work, and I'm going to teach you a shortcut. Let's say I have 3 segment lengths. Let's say I had a triangle or a side that measured 2 inches, and another side that measured 3 inches, and then the last side that measured 6 inches. Could I use these 3 segments to form a triangle? Would this work with my triangle inequality theorem? Remember how we add the 2 sides and it has to be greater than the third? What happens, and the biggest thing you should always try is take the 2 smaller ones first. What do you get when you add 2 plus 3? 5. Is 5 greater than 6? So right there is telling you that these 3 segments would never close up and form a triangle.
6 is greater than 5.
But it has to be the 2 sides added together. So if we go, these 2 added together have to be greater than this other side. So if it fails, you know those will not form a triangle.
But why could it be the other way around? Like, why couldn't it be
Well,
greater than 2?
it can be. But if you pick the smaller ones first, then you don't have to go back and check all the other ones.
Oh, okay.
All right? Okay. And we're going to see, I'm going to show you a shortcut instead of trying to do all 3. The shortcut way to do it is to add and subtract the 2 sides and see if the other number fits in between. But we're going to see that in a minute. All right, anybody still need this slide? All right, next, another example. This time they're giving us the angle measures. Okay, we want to find the longest and the shortest side. Now, what do you think we need to do first, Michael?
Add up and then subtract from 180.
Perfect. We need to get all 3 angle measures in there before we can determine the longest and the shortest side. Bless you. So I'm going to add the 105 and the 46 first. And I get 151. And then I'm going to subtract that from 180. And I get 29. So this angle up here is 29 degrees. So that really made a difference, because if I would have answered my question using only 46 and 105, I would get the wrong answer. So I can see that the longest side is obvious. It's across from the 105, and it's going to be this IT. because it's opposite the 105. So the longest side is IT. But the shortest side, if I wouldn't have figured it out, I would have thought that it was TJ, but really it's opposite the 29, so it's going to be IJ. So you need to fill in all the angle measures before you look for that longest or shortest side. Does that make sense? This part of it's common sense. You just look for the one opposite the biggest or the smallest, depending on what they're looking for. All right, next one. It's asking us to complete these blank lines with either the less than symbol, the equal to symbol, or the greater than symbol. Now, they didn't give me a picture. I highly recommend you draw a picture so you have a nice visual here. So I'm going to go ahead and draw, and it says given triangle ABC is a right triangle. The only stipulation on the angles was C had to be the right angle. So over here, it didn't matter where I put A and B, just as long as C was next to the right angle mark. So now it wants us to fill in, now that I have a visual, with the less than, equal to, or greater than. So the measure of angle C, what is it in reference to angle A? Greater, less, or equal? Greater. So I put that symbol there. Then it's asking me the measure of angle C. What is it in relation to A plus B? It's not less, it's not greater, it's equal to. We learned a corollary. Remember, these two angles are complements. So if you have a right triangle, that the other two acute angles are always complementary. We learned this a while back. But if you forget it, just remember the three angles of a triangle add up to be 180. If you subtract out that right angle, that leaves you 90 for the other two.
But it could be like one could be like 30.
It doesn't matter, yeah. It could be. One could be 30, one could be 60, one could be 10, one could be 7, it could be 80. As long as they add up to 90, they're equal. All right, what about segment AC compared to AB, Juliana?
Less than.
Good. It's less than, because AB is opposite that 90-degree angle, which is the biggest. So AB is bigger, so AC is less than that. Does that make sense? All right, so draw in pictures. Just remember when you have a right triangle that right angle is 90 and the other two are going to add up to be 90. Anybody still need the slide? Okay. All right. So here it says the lengths of two sides of a triangle are 8 and 13. It says then the length of the third side must be greater than blank but less than blank. So what we're going to do here is the shortcut of that triangle inequality theorem. Okay, so I'm going to show you a shortcut for this. So before we showed all those different inequalities, the easiest way to do this is to take the two sides, subtract them, and add them, and the other side, the third side, must be in between there. So when I subtract and add, so it must be greater than 5, but less than 21. So all good numbers or good options for that third side would be the numbers 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Any of those numbers in between, even halves. Okay, so any number greater than 5, but less than 21. So it would be less than the difference of the two sides, but greater than the difference, but less than the sum. So that third side needs to be in between.
So for the 21 one, you could put 20, 19, 18, 17.
Correct. Okay. You could even put 5.01. As soon as it's bigger than 5, it's good for that third side. Or less than 21. Could be 20.9999. As long as it's less than 21, but greater than 5. It would be a good length of the third side. That's the shortened version of this. Add and subtract the two sides. And then the last slide is more examples. Now we're going to apply this. Now, best way to do it, take the two smaller numbers. Because if it works for the two smaller numbers, then you know it's going to work. So for example, if I add 6 and 8, what do you get? 14. If I subtract 6 and 8, what do you get?
2.
Okay. Is 10 in between 2 and 14? Yes, it is. So this works. Let's try 3, 4, and 8. If I add 3 and 4, what do you get? So right away you can see that it's not going to be big enough. So this one would be no. If you subtracted them, you got 1. So it actually would have to fall in between 1 and 7. And 8's too big. Then for the next one, you're going to add 2.5 and 4.1. And I get 6.6. And then if I subtract them, already we can see. Subtract just to show. And it needs to be between 1.6 and 6.6. And because it's 5, it fits. So this one's yes. And then notice on D, they're not in order. But I'm still going to take the two smallest. So here, if I do 2 plus 4, what do you get? Okay? Is that greater? Is that smaller? So it's not. So then if I subtract them, 4 minus 2 is 2. So it has to be in between 2 and 6. Because it's 6, it's not working. It has to be less than 6. Can't be equal to. And then the last one, if I take the two smaller, 5 and 6, if I subtract them, I get 1. If I add them, I get 11. This other 6 fits in there, it's good to go. So this one's yes. So just take the two smaller ones, add and subtract them, and see if that third number is in between. Doesn't have to be in the middle, just have to fall somewhere in between those numbers. Any questions on this lesson? Okay, so tonight we're only spending one day on this lesson. So your homework over the weekend is practice B. And then on Monday we are going to learn 5-6. And that'll be the last lesson that we learn before the test on Thursday. Okay, any questions?